Hi, I want to review the four laws that make up Maxwell's equations and also a piece that kind of goes along for the ride, talking about the total force that a charge will feel when we're dealing with electric and magnetic forces. So the four Maxwell's equations start with Gauss's law for flux. So if we have a closed surface integral of the electric field dotted with an area vector, our total electric flux through a closed surface, that's going to be equal to the charge enclosed by our Gaussian surface divided by epsilon naught. And for magnetic fields, the closed surface integral of the magnetic field dotted with the area is equal to 0. And that's because magnetic field lines have no beginning and end, whereas electric field lines begin and end on charges. So since we don't have isolated magnetic charges, then we're not going to be able to have a net magnetic flux through some closed surface. Now, these two pieces are based off of fluxes. The next two pieces are based off the circulation of fields, how fields flow around some path. So if I calculate the circulation of the electric field around some closed path, that's going to be equal to minus the change in the magnetic flux passing through the surface that is created by that path boundary that we've established. And remember, that surface doesn't have to be just a simple, if I draw a circle inside that, it could be any distorted, distended shape. We would have that same change in magnetic flux through any possible surface. And similarly, if we look at the magnetic circulation around a loop, that would be equal to mu naught times any true current that is passing through a surface bounded by that loop. That's what I call I enclosed, plus any displacement current, which would be equal to epsilon naught, the permittivity of free space, times the change in any electrical flux passing through the surface that we've created with that boundary of the path where we're looking at the circulation of the magnetic field. And now the last piece for forces, which is also sometimes referred to as the Lorentz Force, the total force acting on a charge would be equal to that charge times the sum of the electric field plus the cross product of the velocity of that charge with any magnetic field that we have. Now, this, I want to point out, is one of two ways where you will sometimes see Maxwell's equations. This is the integral form. There also is a differential form involving the gradient operator and divergence and curl, but that's a topic for a different class. Thanks for watching.